The James Webb Space Telescope just spotted something that has astronomers both excited and nervous at the same time. An asteroid is heading toward the moon right now. Webb captured images of this space rock in infrared light, and what those images revealed changed everything scientists thought they knew about its path. This asteroid was originally flagged as a potential threat to Earth. After months of tracking and observations from Webb, scientists ruled out an Earth impact. But when they ruled out Earth, they discovered the asteroid might hit the moon instead. Webb's observations could give scientists the first real-time view of a major lunar impact in human history. Asteroid 2024 YR4 is between 53 and 67 meters across. Picture a 15-story building tumbling through space. Telescopes in Chile spotted it on December 27, 2024, and within hours, alarm bells started ringing. Objects this size hit Earth maybe once every few thousand years, but when they do, the damage is catastrophic. That's why this asteroid became the first ever to trigger a full coordinated international planetary defense response. Ground telescopes could only tell scientists so much. Ground telescopes rely on sunlight bouncing off objects. Webb uses infrared sensors that detect heat signatures. When Webb pointed those sensors at asteroid 2024 YR4 on March 26, 2025, it revealed details that ground telescopes simply couldn't capture. The data improved scientists' understanding of where this asteroid will be on December 22, 2032 by nearly 20%. But Webb wasn't done. On May 11, 2025, the telescope made one final critical observation before the asteroid moved too far away to track. And that's when the calculations shifted in a way nobody expected. When the asteroid was first discovered, computer systems calculated a small chance of Earth impact in 2032. By February 2025, that probability had climbed to 3.1%. In planetary defense, that's one of the highest probabilities ever recorded for a large asteroid. By late February, scientists finally had enough data to make a definitive call. The asteroid would not hit Earth in 2032. But when scientists ruled out an Earth impact, the calculations revealed something else. The asteroid's path would take it extremely close to the moon. After Webb's March observations, the probability of a moon impact stood at 3.8%. Then came those crucial May 11 observations. The data pushed the probability up to 4.3%, and that probability was frozen at that point because the asteroid had faded from view. Scientists don't track just one possible path for an asteroid. They track thousands based on tiny uncertainties in measurement. Right now, there's a 95.7% chance the asteroid will miss the moon entirely. The 4.3% represents all those possible paths that actually intersect with where the moon will be on December 22, 2032. The collision would throw material from the lunar surface into space at incredibly high velocities. Some of that material would escape the moon's gravity entirely and enter Earth's orbit. Research suggests some of this ejected material could reach Earth within just a few days. Imagine a meteor shower made of pieces of the moon. For scientists, this would be a dream come true. They've studied thousands of lunar craters, but they've never actually watched one form. Earth has a protective shield that the moon doesn't: our atmosphere. When objects the size of 2024 YR4 enter Earth's atmosphere, they typically explode in the air before reaching the ground. The moon has no atmosphere, zero protection. Asteroids this size hit the moon once every 4,000 to 5,000 years. But here's why this matters now. NASA plans to send humans back to the moon. There's a lunar orbiting station called Gateway scheduled for deployment before 2032. If 2024 YR4 hits the moon, the debris field it creates could threaten future lunar missions and infrastructure. That's why scientists are paying such close attention. The asteroid was discovered 2 days after it had already passed its closest point to Earth. Why? Because it approached from the direction of the sun. Ground-based telescopes face a massive blind spot. There's a whole region of space they simply cannot see. You might remember the Chelyabinsk meteor from 2013. A 20-meter asteroid struck Russia with no warning. It approached from the sun's direction, damaging thousands of buildings and injuring about 1,500 people. Now imagine if that had been 2024 YR4 instead. 3 times larger, 3 times more destructive. ESA is developing a space telescope called NEOMO to fix this blind spot. The problem? NEOMO won't launch until the early 2030s. Until then, the blind spot remains wide open. Ground telescopes measure an asteroid's size by seeking how bright it appears and estimating based on assumed reflectivity. A dark asteroid looks smaller than it actually is. A bright, icy asteroid looks larger. Webb eliminated that uncertainty. Its infrared sensors measure the heat signature directly, no guessing required. Webb gave scientists a precise estimate of the asteroid's size, about 60 meters in diameter. After Webb's observations, the probability of a moon impact actually increased because the refined data showed the asteroid's trajectory was different from what was initially calculated. A 1 centimeter per second difference today means thousands of kilometers of difference 7 years from now. Webb's precision transformed rough estimates into reliable predictions. The asteroid is too faint and too far away for any telescope to observe. For the next 3 years, that 4.3% probability sits frozen. When the asteroid comes back into view in late 2028, scientists will immediately start taking new measurements. Within weeks, maybe even days, astronomers will know for certain whether the moon is getting hit or getting a close call. If the probability stays high after 2028 observations, there are only 4 years until the potential impact. Could humanity actually do anything about it? Should we even try to deflect an asteroid heading for the moon? Those are questions scientists are already starting to debate. But for now, all anyone can do is wait.